Assalamu alaikum and good day, gentlemen. My name is Naif Al-Huwaikan, and this presentation is part of the requirement for the degree of Master of Engineering Management in KFU-BM, supervised by Dr. Layth Al-Hadidi, where I would like to thank him for giving me the full support and guidance to complete this research. The presentation title is to conduct root cause analysis of a human error in BM activities, a large oil and gas company in Saudi Arabia. So, to summarize the research highlights, the purpose of this paper is to conduct root cause analysis and provide recommendations to improve human performance, as human performance plays a major role in the success of the maintenance activities in each organization. Accordingly, structured questionnaire has been conducted where lacking QA/QC program found to be the main cause of human error in the BM activities for the studied organization. Also, Markov method used to analyze human performance, which recommend to add QA/QC program as the availability of the system found to be increased by 20% and the human error dropped from 30% to less than 5%. On the other side, QA/QC will shift the responsibility from the maintenance task performer to the QA/QC inspector, which might lead to increase the level of dependency for the line maintenance craft. The maintenance cost will increase as more craft is needed to apply QA/QC program and the repair time as well. This presentation will shed the light on the following topics. Introduction, the objective of this research, then literature review, after that methodology, following that results and discussion, finally conclusion. Human performance plays a vital role in the success of the maintenance activities in each organization, where a simple mistake can lead to a catastrophic failure. So, let us start with the facts. More than 50% of equipment and machinery fail to perform correctly after maintenance work. A percentage of around 30% of electronic equipment fail consequently after operational or maintenance error. In 1988, in the United Kingdom, due to maintenance error in wiring repair, there were 30 fatalities and 69 severe injuries at the Clam Junction Railway. In 1989, in Texas, due to maintenance error, 66 Phillips Houston chemical complex exploded, resulting in huge damage to property and land. In 1993, a study was conducted on 122 maintenance-related accidents, categorized maintenance error into 4 groups, as were 56 due to omissions. Thus, the objective of this report is to investigate the root cause of a human error in one of the large companies in Saudi Arabia. Also, to provide a discussion about the main cause of a human error investigated in this study. In addition to that, providing methods and measures for improving human performance in the existing BM system. Starting from the basic, maintenance is any activities that keep the facility in as-built condition and therefore continuing to have its original productive capacity. Where we have 3 types of maintenance: corrective maintenance, preventive maintenance, and predictive maintenance. Corrective maintenance and scheduled maintenance to retain the facility to defend the state, where preventive maintenance, all actions carried out on a planned and periodic to keep the facility in a stated working condition. Predictive maintenance, the use of modern measurement to diagnose the facility condition during operation. As per the BF curve, which represent these 3 types of maintenance, usually as much as we diagnose any symptom of system error earlier, as much as we can avoid any catastrophic failure where the machine will run till fail. Then, human error. Basically, it is defined as any deviation from expected human performance, as mentioned in Sanders and Mori paper. What leads to human error? There are 3 main factors that interact and lead to lack of human performance. People, and example for that their fitness and stress management system, example for that organization training, incident investigation and risk assessment. Finally, facilities and equipment, and example for that workplace design and equipment design. The research significance is mainly because human performance plays a vital role in the success of companies, as mentioned before. Human performance can largely improve the company's performance and have a direct impact on the productivity, hence the profitability of the company. Also, there is insufficient research that discusses the main cause of human error in this facility. Now, moving to the literature review. Wiesnard and Hollingel in 2012 said, in the past years, there are several severe industrial accidents that happened and caused loss in workers' life and workplaces. Piper Alpha disaster in 1988, Bhopal gas plant disaster in 1984, Chernobyl nuclear power plant disaster in 1986, and BP Deepwater Horizon oil spill disaster in 2010 are examples of these accidents. Dillon in 2014 found that poor repair job could lead to an increase in the number of equipment breaking down and needing a repair. This will increase the repair jobs and will in turn increase the chances of personal accidents. For that, solving the basic usually eliminates a lot of future problems. Reliability and maintenance engineers emphasize on inspection systems and maintenance processes to keep unplanned activities at its lowest. Such emphasis will ensure overall cost and risk exposure will remain at the absolute minimum, as per Hamid, Asadzadeh, and Azadeh. Also, to guarantee economic, environmental, and social sustainability are saved, as per Franciosi, Maki, Savino. Bao and Ting in 2014 found that, from maintenance point of view, human error accounts for about 91% of all troubles, and those are primarily found to be in inspection and installation of components of a given system. Pavasar and Srinivasan in 2015 said, the main cause of over 70% of all oil and gas industry major accidents is due to human error. Alipur and De Pasquale has found that errors committed by workers are responsible for about 50 to 90% of industrial accidents, and the majority of these errors occurs for conducting the wrong maintenance activities. Moving to methodology section. Two methods have been used in this study to analyze the root cause of a human error. First one, structured questionnaire directed to the related employees and experts in PM activities to rate the main cause of human error. Then, Markov method to perform human error analysis in maintenance work and to prove the questionnaire results. Starting with the questionnaire, which has been developed based on the following. Previous related studies were reviewed to identify the main causes of a human error. A pilot study was conducted with a selected group of experts to verify the identified human error causes. A final version of the questionnaires was prepared that incorporates all the comments and remarks from the pilot study. The questionnaire divided into two sections. In the first section, a brief introduction is provided about the study and its purpose. The respondents were asked to provide general information such as their years of experience, position, and other personal information. In the second section, the respondents have been asked to rate the main cause of human error in their organization during the PM activities. As we can see in this page, the questionnaire question to be rated from 1 to 5 based on the participant experience and the PM tasks. Examples for that: exhausted maintenance craft, lack of training, shortcut and equipment design. These are listed after consulted with the expert and the previous studies. Why we selected rating method? According to Flynn in 1990, this technique has no limitation compared with the ranking scale, whereas the number of items to be compared must not exceed a few items. The figure shows that the mental effort is much less for rating compared with ranking 4 times. Next page, the calculation of average rating is performed as follows, where the count number of responses multiplied by the weight assigned for the answer choice divided by total number of responses. The weight assignment for a question that has 5 answer choices are as follows, where 5 is the highest and 1 is the lowest. Then we applied Cochrane formula to calculate the sample size and 19.5 confidence level. We found 97% is the best sample size. Accordingly, the total participant number in this survey is 103 employees with different years of experience. As shown in this figure, most of them have less than 8 years of experience. Now moving to the research results. As shown in the figure, the main causes of a human error of 3 categories of maintenance tasks, electrical, mechanical, and instrumental, are presented as follows. Lacking adequate QA/QC in maintenance is the main cause of failure for electrical and mechanical PM tasks, as per the respondent. Poor equipment design is the main cause of failure for an instrument PM task and lacking adequate QA/QC. Shortcuts and not following maintenance procedure are the second cause of a human error, as per electrical respondent, where fatigued maintenance personnel is the second reason, as per mechanical respondent. Improper work tools is the lowest cause of a human error, as per the participant feedback, for 3 categories. Most of the respondents believe that lacking QA/QC is the main cause of most of a human error in their facilities. Therefore, we have applied Markov method to analyze the system availability before and after adding QA/QC program, assuming maintenance craft perform tasks normally at initial state. All failures are statistically independent. All transition rates are constant. There is only one repair facility. Thus, the first model has been built, where at the initial state, maintenance craft perform maintenance activity normally. The maintenance craft may commit a human error at a failure rate of lambda. When the craft committed a human error, the system can be restored to its initial state, as good as new, at repair rate of mu. Based on the proposed model, the equation describing the system using the Markov method were obtained as shown. After developing the system equations, then taking the limit and inverse Laplace transform, we obtain the following equations for the system availability. Similarly, another model has been developed adding QA/QC to the system. We built the same equations till we obtain the system availability formula. After solving these equations, we got 2 figures representing the system availability and the human error percentage before and after adding QA/QC. As you can see, the availability of the system when there is no QA/QC will drop from 100% to 70% at the state of performing maintenance tasks normally after a certain time, where the probability of the craft committed a human error will increase from 0% to 35% until both of them will reach to the steady state. On the other side, when QA/QC added to the system, the availability will be increased to 90% and the probability of having a human error will drop to less than 5%, where the rest of the 15% is represent the system under QA/QC inspection. According to the above mentioned findings, it is highly recommended to apply QA/QC program in PM task, as it will increase the system availability by 20%, and it will reduce human error to less than 5%. However, there are several challenges that might be resulted after applying QA/QC, such as the responsibility of the PM task quality will be shifted from maintenance task performer to the QA/QC inspector, which might lead to increase the level of dependency for the line maintenance craft. Moreover, the maintenance cost will be increased as more craft is needed to apply QA/QC, as the repair time will be increased as well. To conclude my presentation, human performance plays a major role in the success of the maintenance activities in each organization. Lacking QA/QC program is the main cause of human error in the VM activities for the studied organization. Based on Markov method analysis, it is recommended to add QA/QC program as the availability of the system found to be increased by 20% after adding QA/QC, as the human error dropped from 30% to less than 5%. QA/QC will shift the responsibility from the maintenance task performer to the QA/QC inspector, which might lead to increase the level of dependency for the line maintenance craft. The maintenance cost will be increased as more craft is needed to apply QA/QC and the repair time as well. With this, I conclude my presentation and I would like to thank you for your listening.